Assalamu alaikum warahmatullahi wabarakatuh. I hope you guys are doing great and welcome to another computer science lecture. We were discussing section number 7, algorithm design and problem solving, and we have already discussed till section number 7.6. So today we are going to start section number 7.7, that is trace tables or the dry running of an algorithm. This is basically the statement from your syllabus: using trace tables to dry run an algorithm. A trace table is set up with a column for each variable and a column for any output. Means all of the variables in your algorithm, in your program, have one dedicated column in the trace table, and there is an additional column for the output. It can be used to record the results from each step in an algorithm. It is used to record the value of an item, a variable or constant each time that it changes. The manual exercise of working through an algorithm step by step is called a dry run. Dry run is always very much important. Whenever you write an algorithm, you should dry run it so that you are certain, you are sure that you have not made any mistakes while making that algorithm. Test data is then used to dry run the flowchart or the pseudocode and record the results in the trace table. Now this test data is most of the time it is normal data. Okay, the test data is always given in the question by the examiner, and there is always at least one question of about 6 to 8 marks in Cambridge paper number 2 that is concerned with dry running an algorithm. And in that question, test data is always provided by the examiner. In fact, he even provides you with that drawn trace table, just that it is blank and you have to read through the algorithm and solve the trace table. The second thing you need to remember is that this is a very important topic, so you should have a very good practice of it. Solve as much questions from the past papers as you can, as there's always, no matter what the variant, there's always at least one question of this type in your paper number 2. Secondly, whenever you write an algorithm, be it a flowchart or a pseudocode, you should always dry run it so that you're certain that it does not contain any errors. During a dry run, every time the value of a variable is changed, the new value is entered in that column of the trace table, and every time a value is output, the value is shown in the output column. Looking at the output, it can tell us the purpose for the algorithm as well. Consider the algorithm represented by the following flowchart, and you're given a set of test data 9, 7, 3, 12, 6, 4, 15, 2, 8, 5. Test data can consist of both normal and abnormal data. This is the trace table. I hope you guys are able to see it. Start A0, B0, C is 100, input X. If X is greater than B, then put the value of X in B. Otherwise, if X is less than C, then put the value of X in C. Else A equals to A plus 1. And if A is less than 10, then repeat the process. This is how we denote a loop in flowcharts. So this basically means until A reaches the value of A, until A is less than 10, you keep on repeating this process, this loop, and after A has become 10, simply output B and C. So we'll start with our first test data, that is 9. So input A, C. Over here, X, A, B and C, these values have been initialized, and then first of all we are going to input 9 in the X column, because okay, then we have X is less than B, B is 0, X is greater than B, Yes, x is greater, 9 is greater than 0. If yes, then put the value of x in b. So this 9 would come into this b. Is x less than c? Means is 9 less than 100? Yes, it is. So put this 9 means the value of x in c. Next, a equals to a plus 1. So 0 plus 1 would become 1. A is less than 10. Yes. And then we'll come to the next value, input x again. The next value is 7. So we put 7 over here, and in the similar way we again pass it through these two checks unless and until we reached a equals to 10, and then we output are the values of b and c, the final values of b and c, and we do not put comma in between them, although there is a comma in between these two variables. But in the final output, if there is a comma between two variables, we do not include it. It can be seen from the output that the algorithm selects the largest and the smallest numbers from a list of 10 positive numbers. These were 10 positive numbers, and what has been output? The largest number and the smallest number. The same trace table could have been used if the algorithm had been shown using pseudocode. Next, we have a practice task. Following flowchart: input the size of a number of car engines. A value of -1 stops the input. The following information is output: average engine size and number of engines with size greater than 1.5. Complete the trace table with this data. This is the algorithm and this is the trace table. So I'm gonna show you a little bit of how to solve it, not the complete part. You can solve it yourselves. Okay, so first thing is in engine equals to 0. The first thing is start engine 0, count 0, number 0. So in our first line, these three would become 0. As we do not have any more initializations, so we are not going to write anything for size, average or output. Input size, the first size is 1.8, and we are going to, it's better if you start from here, but 1.8. Then is size equals to -1? No, 1.8 is not equal to -1. Is size greater than 1.5? Yes, 1.8 is greater than 1.5. Then count equals to count plus 1. So 0 plus 1 would become 1. Then number equals to number plus 1. Again 0 plus 1 would become 1. Engine equals to engine plus size. Engine was 0. 0 plus 1.8 would become 1.8. And we are going to go towards the next iteration of the loop, or the next count, or the count equals to count plus 1 part, and we are going to restart the loop because the arrow goes back up into input size and the next number is 2. So we'll simply, whenever one iteration of loop is finished and we start with the next, then we always write it in a new line in the trace table. Now this time it is 2.0. Again size is -1. No, size is greater than 1.5. Yes. So count would be count plus 1. That means 1 plus 1 would become 2. Number equals to number plus 1. Number was 1. So 1 plus 1 would become 2. And next engine equals to engine plus size. 1.8 plus 2.0 would become 3.8. Similarly, you are going to keep on filling the table with the data from over here until you reach -1. Once you have reached -1, your algorithm is going to stop, and when it is -1, then what you are simply going to do, you are going to calculate average. For doing that, you will divide engine by number, means whatever is the value of engine in your last row in the column of engine, the last value, like right now it is 3.8, you will divide it by number. Let's suppose if the next line is -1, for example, then that would mean I'll have to calculate average. 3.8 divided by 2 would be something like 3.8 divided by 2, that would be something like 1.9. so I'll write 1.9 over here. Then what I have to do next, output average and count. So I'll simply output. Okay, one thing you need to remember is that some students write the output over here. This is wrong. Whatever is your last line in your trace table, you have to write down the output in front of it. Okay, so output is average and count. Average you just calculated 1.9, and then you have to write count, that would be 2. This would be your output. This is not correct right now because I have stopped in after taking just 2 values, whereas when you'll actually run the trace table, there are about 1 2 3 4 5 6 7 8 9 10 values. So do it yourself. I'm not going to solve the complete table, so you may have some practice, and you'll find these type of questions in every variant, in every past paper, in every paper 2 of Cambridge 2210 or Cambridge IGCSE Computer Science. So go ahead, solve a handful of trace table questions because they really do come handy. Trust me, you wouldn't want to lose your 6 to 8 marks just because you have not done enough practice. Besides, the trace table questions or dry running of an algorithm is very easy once you get the hang of it. So go ahead, knock yourself out with the practice. Remember, the paper 2 topics are only helpful to you if you solve their past papers and do lots and lots and lots and lots of practice. Just there is nothing to remember, there is nothing to memorize. There are only concepts which are to be applied on questions. Paper 2 is entirely, or around 90% of paper 2 is conceptual. So just remembering definitions and method is not enough. You have to do a lot of practice. That's it. That's all you need to know for dry running of an algorithm and for filling trace tables. So I'll see you guys in the next lecture. I hope you have understood everything. Please feel free to contact me if you have any problems. Post your comments down below, or you might just want to let me know about the cons and pros of my lectures. Please do leave comments. I hope you guys have understood everything. Please subscribe my channel and support me. Tell your friends about it as well. Take care. Allah Hafiz.